See how to search in a rotated sorted array. In this question, we are seeing that the number is sorted in ascending order with distinct values. So there are no duplicates. This is a very important point. And the number is rotated. So it is rotated normally in the anti-clockwise direction. And unknown pivot, we don't know where it is rotated at, and so we have to search for an integer target in this rotated array. So if it is not there, we need to return -1, and the complexity has to be O log n. So the difficult part is this one. So if the complexity is not mentioned, we could just linearly search this array to find the value. Otherwise, now since we need to have a complexity of O log n, so when we see this complexity O log n, we know this complexity is achievable through binary search. So binary search requires a sorted array, but this sorted array is rotated. So to do this, we have to first analyze how an array of this sort looks like. So we have an array like this. So the length of this is 9. So if we search for the middle, so let's see how we can apply binary search to this problem. It is very important that you should read this answer tutorial on binary search. It is very interesting. So I'll share the link with this tutorial. So if we are going to do binary search here, so the middle element is 8. So we have to see how we have to search for, suppose number 9 here. So the middle element is here. I am going to search for 9. So if you look at this elements, number 4 is less than 8. So this whole section is in the sorted order, and from beyond 8 we don't see a sorted. So up to 9 it is sorted, but we have only discovered 8 as a middle element, so we don't know. We can see that this part is not sorted. So we can see that if 4 is less than 8, then this part is sorted. So now what we have to check now is, in this case, we can decide this middle element, first element, and the rest of the elements. So if first element is less than or equal to the middle element, so this less than equal sign is for the edge cases. So suppose there is only 2 elements in the array, there is only 4 and 5. In this case, 4 alone is sorted. So we have to say first is less than mid element. So in that case, if we are searching for a value like 5, we know this has to be here, because 4, we are checking 4 is less than 8, so this must be sorted, and 5 is greater than 4, so we know this element has to be here. So if target is less than mid, and if the target is greater than or equal to the first element, we can search the left hand side. So I'm just writing down this here as a pseudo code. So search left. Else any element that is not under this condition, like we are looking for 9, something greater than greater than the mid element, or if we are looking for something that is greater than, less than the first element, then we are looking at this, the right hand side. So we will search for the right hand side. Search right. So let me type in another array. Now I have the same array that is rotated further. So now when we look at this and find the middle element, so this would be the middle element. So if we look at this one, this array is sorted from to the right. So this is a special case. This part is also sorted because this is the exact pivot point. So now this will be the else part here. So this array is sorted to the right. So what we have to see now here is, so we are going to consider this array if target, so if the target is here, then target should be greater than the mid and target should be less than or equal to the last element. So if that is the case, we are going to search the right hand side of the array, else we are going to search the left hand side. So initially we have to check whether target is equal to mid. If that is the case, we can return that, or and so on. So this is the basic logic. In this example, all elements are distinct, so we don't have to worry about duplicates. So I am going to code this using the recursive method of searching, binary search. We can do it in the non-recursive manner also, but if the recursive manner is more comfortable, because if we are going to have duplicates in a future question, this will be very helpful to solve that problem as well. So here, so let's create a new function, call a new function that will have the we have to have this search left and search right. So here we'll pass the start and the end elements. We'll also pass the array here, and also the target. I will create a private function that will search, and it will have the start element and the int. So it will have the array here, and it will have the end element, the last element, and last element's index, and then the target. So now we have this function. So let me first define this one. Mid index would be start plus and minus start over 2. So this will be the middle element index. So I will have the mid element like this, nums mid index, and I will have the first element of the array as this, nums start, and the last element of the array would be like this. So let's define our if statements. I can just use this one. I can copy this here onto the code. So target less than mid and target greater than or equal to first means we are going to search left. So left means start. So initially we have to check this case. So we have to set if mid equals target. We have found our use case, so we will return the index of mid index. If there is another case, the error case. So if and start is greater than end, then we return the -1. We have not found our answer. So we are going to search left. This is nums, so it will be search start to mid -1. We have already checked for mid, so we don't have to worry about that. So mid -1 and the target here. Search right would be nums start, so it will be from mid +1 to end, and we are searching for the target. And the same thing here, so we'll just copy paste it here. This case we have to verify. I will write it here on this one itself. So we have two numbers like this, 8 and 1. So if this will be 0 and 1, so the mid will be 0 plus end minus start over 2. That will be 0, and the target is 1. Mid is nums mid index. So that is, this one is the mid. And if first is equal, first is this, so first is equal to the mid, so it goes here. Target is not less than mid. So we are going here, mid. So we have to use this return statement here. We are searching for 1. So we are going to search nums. Mid +1 is 1, comma, and is 1. So we are here. So start plus, so mid will be here 1, 0, 1. So we are, this will return mid index. So that's correct. So this equal sign is okay. So now suppose we have 1, comma, 8, and we are looking for 1. So it will come here and it will return from here. So that's good. So this less than equal sign is okay. We always have to check with two numbers. Let's run this and see. There might be compilation errors. Let's run. Start is should be end. No? Oh, that's good. Oops. Oh, I have just made this should be search right, and this should be search left. I have made a mistake in copy pasting it. This should be search left. So there's one more mistake here. So I hope you have found it by now. So instead of, I should have used the mid index instead of the mid value itself for the index. This is one of the very silly mistakes we all make. So we have to be very careful when we code. And let's see if there are other mistakes. Let's go and submit it and see. So we have this code passing the tests. So that's all. Please subscribe. Thank you.